Hi everyone, welcome to the episode 20 of XCA ByteCast, a series of bite-sized tips and tricks that you can use in any of your project. In this video, we're diving into building a custom WebSocket client with some powerful features like a ping scheduler to maintain connectivity in the long run, network monitoring to detect connectivity changes, for example when the network is down and then come back online, a Reconnect mechanism for reliability, and we're going to build using Swift Structured Concurrency Global Actor for thread safety without the need of GCD. First, here's a glimpse of what the final client will look like in action. We'll test it using OpenAI ChatGPT real-time WebSocket API. As you can see, this is very simple to use. Just initialize, pass the URL. In this case, this is the OpenAI real-time API. And can pass additional header. In this case, we pass the OpenAI API key and this OpenAI beta real-time v1 as the additional header. Okay. Can also set the ping interval and try reconnect count limit before it reconnects after failure of ping and pong. And we simply connect and attach a closure when it receives the data. Okay. And we can also attach connection status changes. So this will be printed when the client connection state got updated, whether it's connected, connecting, or disconnected. Okay, now let me show you. Here it's already connected to the OpenAI real-time API WebSocket server. So they're already sending ping and pong. Now let's try to send a prompt. What if WebSocket? Okay, as you can see, we got the response in real time. Okay, ChatGPT real-time WebSocket server receive. Okay, so this closure got invoked when we got the data. And this is the response. WebSocket is a communication protocol that provides full duplex communication channel over a single TCP connection. So this is the demo of the WebSocket client that we are going to build. Now let me stop this and close this. Before we begin to code, let's start with some basics. Okay, I have prepared these slides for you to see. Okay, so what is WebSocket? It is a big directional full duplex communication protocol. So unlike HTTP, which is a request response based, in HTTP the client must initiate every interaction, but with WebSocket, both the client and server can send message independently at any time. So this makes WebSocket ideal for real-time application like chat with the chatbot, live updates, or gaming. Okay. So what's the state of WebSocket in Apple platform such as iOS and the other? So iOS provides URL session WebSocket task, which is great for WebSocket connections. However, it's missing a few critical features. So it doesn't provide a built-in ping scheduler. So we have to manually ensure that the server connection stays alive. Okay, because we need to ping the servers periodically, so the server doesn't disconnect the long-run connection. Okay, and there is no network monitoring. It doesn't detect when your device is offline or handle the reconnection automatically. So the on-receive data API is also very cumbersome. It requires recursive handling, which can get very messy. And yeah, this is only available on Apple platforms, iOS, macOS, watchOS, Vision, or tvOS. But in this video, I'm not going to add Linux support to this, but we actually can using Swift Neo. Okay, so what's the solution for us in Apple platforms? So basically, what we are going to build is a custom WebSocket client on top of URL session WebSocket tasks. This custom client will address all of these limitations and provide a much better experience for the users of our WebSocket client. It will be easier to use, reliable, and robust, making it perfect for real-world application. Okay, so these are all the features that we are going to add for our custom WebSocket client. It's going to be built on top of the URL session WebSocket task. Okay, so that's basically for the overview. Now let's begin the implementation. So open Xcode and just click new project. So for this, we're just going to create a Mac OS command line tool. Okay, so give it any name that you want. So I'm just going to give the name of WS client. Okay, save. Okay, it's created, and let's create a new zip file and give it a name of WebSocket client. Okay, let's bring this to full screen. Okay, so now let's build this step by step. We'll divide the implementation into logical chunks to make it easier to follow. Okay, so the first part is to define configuration and connection state model. Okay, so let's begin by declaring a model, a struct, give the name of WebSocket configuration. Okay, and in here there will be the first property will be this additional headers. This is a dictionary string that we can pass when constructing URL requests. So when we want to inject the header, for example the authorization token and others. And the next one is this ping interval. Okay, so the interval, periodic interval, where we're going to make the ping to the server to maintain the connection. Okay, and the next one is this ping try reconnect count limit. Okay, so this will determine when we should disconnect and reconnect to the WebSocket server after several of our previous ping doesn't receive a pong from the WebSocket server. Okay, you will see that later in the implementation. And let's create the initializer for this. For the additional headers, we can pass empty dictionary for the default value. For the ping interval, let's pass 20 seconds. Okay, every 20 seconds we make ping. And then ping try reconnect count limit, let's set the default value to 3. Okay, so after 3 times we make a ping and the server doesn't give us a pong, we will disconnect and then reconnect to the server, initiate a new handshake. Okay, so this is the struct for the WebSocket configuration. And then let's declare an enum as well, give the name of connection state. So this will be the state of our connection, whether it's going disconnected and connecting and finally connected. Okay, so for example in our front-end application we can display indicator when it's disconnected. We just show a red dot connecting, maybe orange dot, and connected we will show a green dot. Okay, this enum will help us achieving that. We will add this as a property to the WebSocket client. Next, let's create a global actor and give it a name of WebSocket actor. Okay, so basically our WebSocket client will run in this global actor. Okay, for the thread safety. So let's create this share. Okay, and then we're going to also make a tab alias for the WebSocket client message, and we are going to tab aliasing the URL session WebSocket task.message. Okay, we don't want to expose URL session WebSocket task.message to the users. Okay, because in future maybe we can change the implementation. Maybe we can create another WebSocket client using the new network framework, or maybe the using a Civ Neo. Okay, so we're just exposing this as WebSocket client.message. And then next, let's mark this as WebSocket actor and create a class WebSocket client. Okay, and then first let's create a private let station, give the name of session, and the type is going to be URL session. And then second one is the URL, okay, that we want to hit WebSocket server endpoint, and then the configuration, which is the WebSocket configuration. And then next one is the monitor. This will be the NW path monitor optional. Okay, so first let's import network to access this NW path monitor. This is going to be used to detect the network changes in case it is offline and getting back online. Okay, and the next one, we are going to declare this private var WebSocket task. This will be the URL session WebSocket task that we are going to make the WebSocket connection under the hood. Okay, so this will be hidden to the user. So the user doesn't need to handle the URL session WebSocket task by themselves. And then let's declare a ping task that we are going to use to basically schedule a ping to the server within a specific interval. So this will be a shift task that can be cancelled. And then let's also declare this ping try count. Okay, and just initialize with the value of 0. Okay, and then we also need to make this WebSocket client conform to NS object, because we are going to adopt the delegate of URL session, and it requires NS object conformance and the use of class. Okay, let's also make this conform to sendable. And let's continue with several other property. So on receive, this will be a callback. So actually I'm going to use result WebSocket client message and the error. Okay, so the user can assign this on receive, and then whenever a message got received on the WebSocket server, this will be got triggered. Okay, so this WebSocket client basically is just enum between binary data and string. Okay, and next we are also going to declare the on connection state change. So this will be also a closure that the user can assign to receive the connection state change. Okay, and next let's declare a private set var for the connection state that the user can retrieve. So the initial value will be disconnected. Okay, and then let's attach a dit set. In here we can simply invoke on connection state change optional and passing the new connection states when it got updated. Okay, and let's create an initializer. Let's make this non-isolated so it can be initialized from different isolation contexts. Okay, and then in here we can simply provide URL as the first param that needs to be passed, and the configuration, which is the WebSocket configuration, and the session URL session. And let's, for the URL session, let's just provide the default value, the default configuration, and then let's just assign the URL, configuration, and session as well to the instance property. Okay, that's it for the initializer and all the properties for the WebSocket client. Next, let's continue by creating a connect method. Okay, and in here let's add a guard, and let's check if the web session task is nil. Otherwise, if it is not nil, we just return. Okay, and for debugging, I'm going to add a print statement. WebSocket task is already exist. Okay, and then here let's continue by creating a URL request from the URL property that we have, and here we can use the configuration and access the additional headers dictionary, and then let's invoke for each. Okay, and in here we can just invoke the URL request add value, the value from the additional item in the dictionary, and the HTTP header field we just use the key. Okay, and continuing on, let's assign the web session task by using session WebSocket task with request. Okay, this will initialize the WebSocket task from the URL session, and then in here we can basically set the delegate to self. Okay, and now we can connect using this resume. Okay, and now we can set the connection state of this to connecting of our WebSocket client. Okay, and then we will declare an extension for the WebSocket client to conform to the URL session WebSocket delegate. Okay, and in here now we need to mark this as non-isolated. Okay, func, and then we want to basically implement this did open with protocol. Okay, in here we want to switch to the WebSocket actor to update our property safely. Okay, and then invoke connection state connected. Okay, so this will be invoked when we are connected with the WebSocket server. And then second one is this non-isolated func URL session did close with. Okay, in here we want to do the same, updating the connection state, but in this case we want to set the connection state to disconnected. Okay, this will be invoked when the connection got with the WebSocket server got closed. Okay, so these are the two delegate method that we implement. And continuing on, we want to add several methods for our ping and monitor network connectivity as well as receiving the message. So let's begin by just invoking it in here first, receive message, and then start monitor network connectivity and schedule ping. Okay, so this all will be private. Receive message and start monitor network connectivity and schedule ping. Okay, now we have all of this, and next we want to also implement we will implement those three a bit later. Now let's continue by implementing a private func disconnect. We will have a private disconnect method with our one parameter, sure remove network monitor. Okay, boolean. Okay, so in here we will simply just cancel the WebSocket task, realization WebSocket task by invoking cancel, and then we also set the WebSession task instance to nil, and the ping task, this is the Swift task, we just going to cancel this so it doesn't keep on pinging after disconnected, and set the ping task to nil, and then let's set the connection state to disconnected as well. And then based on this boolean, if show remove network monitor is true, we will basically invoke cancel on the NW path monitor and then set it to nil. Okay, and we will have one public disconnect method. Okay, disconnect that the user can invoke if they want to explicitly disconnect, and in here we'll pass show remove network monitor to true. So when the user explicitly disconnect, we will remove the network monitoring as we don't need it again, because user has stated that it will disconnect from the WebSocket server. It doesn't need to monitor anything. So that's for the disconnect mechanism, and let's continue by implementing the other methods. There's one method that I also want to add, which is the reconnect. This is also private, internally used here. So in here we will simply invoke disconnect and pass show remove network monitor to false, because we want to keep on monitoring network. in case of reconnect, and then we just invoke connect back. Okay, and let's continue with the receive message. Okay, so in here we can simply invoke web session task receive. Okay, so this is a method that accept a closure, and basically in here we want to simply check, right? And basically in here we want to simply switch to the WebSocket actor, and in here we're going to use web self and just use guardlet self in here, and basically we want to invoke this on receive closure. This is optional. Okay, and then pass the result, so the client of this WebSocket client can receive the results. And remember, this is only invoked once, so to keep on receiving message we need to recursively call this. Okay, so after this we still need to invoke a self receive message. Okay, so you may be wondering why I switched to this WebSocket actor, because the closure that invoked in this receive will be called in the non-isolated context. Okay, so if we just try to call self on here, it will give us an error. Okay, especially with the Swift 6 strict concurrency flag enabled. Okay, so we need to switch to the WebSocket actor. Okay, because this WebSocket client is already marked as a global WebSocket actor for thread safety. Okay, so that's for the received message. And now let's move on to the monitor network connectivity with the NW path monitor. So in here we just need to check, right, if this is got invoked in connect. As you can see in here, we need to check if the monitor is nil, then we will continue, otherwise we will just return. And in here we're going to init, because if you see in here, if the user call disconnect, we will basically cancel and set this to nil when the user expressly disconnect. Okay, so that's why there is this check. And then in here we can simply use monitor path update handler and then assign this. And in here I want to move this weak south. Okay, in here we can simply switch to the WebSocket actor again. So here guard ourselves as return, and in here we're going to check if the path status is satisfied, mean there's a connection, internet connection. Then also if the WebSocket task is nil, okay, then we will call connect. Okay, and then return. And then next, if the path status is not satisfied, means the network is unreachable, then we will basically disconnect internally, but we still want to monitor the network change. Okay, so we need to pass false in here. Okay, because when the network got back online, this will be invoked. If we pass this as true, it will remove the instance and this won't be invoked again. Okay, so and finally, to start the monitoring, we can simply invoke start, and we will just pass the main queue to monitor this, the GCD thread that will be invoked in here. Okay, but as we are using safe structured concurrency, we still need to switch to this global WebSocket actor that we are using in here for thread safety. Okay, now the final one is the schedule ping method. So in this schedule ping, we are going to add a periodic ping to keep the connection alive between the client and server. And then we will also reconnect if needed in specific condition that we are going to implement. So in here, first I'm going to cancel the existing ping task if it exists. and then reset the ping try count to 0. Okay, and then initialize a new Swift task. Okay, and here I'm just going to use weak self in, and in here I'm going to create a loop. Okay, this task, and inside this each loop I'm going to sleep. Okay, sleep using the sleep for seconds. So this will be based on the configuration dot ping interval. Okay, case it is nil, I'll just pass 5. Okay, and then after we sleep, we can simply, oh, I forgot to add the wait, add whether a guard checking the task is cancelled. So only if it is not cancelled, we're going to continue. And if the self exists, and also the task self dot WebSocket task exists. Otherwise, we will just break from this loop while through loop. Okay, and in here, continuing on, I'm going to check if the WebSocket task dot state is currently running. Okay, and then the ping try count self dot ping try count is less than the self configuration ping try reconnect count limit. Okay, so if it is not, then these conditions are met, we're going to continue on pinging. Basically, we're going to increment the ping try count by 1. Okay, and for debugging, let's just print ping send, and then in here, using the WebSocket task, we can invoke this send ping. Okay, and this will be a closure that runs in the non-isolated context. And if let error, we will simply just print ping failed. Okay, error with localized description. Else, we're going to print ping pong received from the WebSocket server. And in this case, we are going to reset the ping try count. Okay, we need to switch back to the WebSocket actor. Let's use weak self to avoid return cycle, and just reset ping try count to 0. Okay, so basically when we make a ping, this will get incremented, and let's say the ping try reconnect count limit, we set this to 2. Okay, so the first time is trying to make a ping, this will be incremented to 1. And let's say when we send the ping, we don't receive the error, this will get invoked again, right? And then we will increment again to basically 2. Okay, and when we make the ping and still we doesn't receive the pong, and this will be invoked again, as you can see with the well through. And in here, in this case, the ping try count is already 2, and then ping try reconnect count limit is, let's say we set it to 2, then this condition is not met. And in this case, we want to add a else condition. Okay, where we just want to reset the URL session WebSocket task. Okay, we're going to cancel that and just create a new one to reconnect. Okay, and then just make sure breaking from this while through loop. Okay, so that's the mechanism of our ping, schedule ping. Okay, this will handle the case when there's no pong received from the server, and then in that case we will need to try to reinitialize the handshake between the client and the server. Okay, in this reconnect, we just disconnect and then call connect, as you can see in here. Okay, so that's the implementation of this schedule ping. Oh, actually there's one more method that I forgot to implement, which is the send method. Okay, this is for sending data to the WebSocket server from the client. Okay, so in here let's declare send. Okay, and The parameter name will be message, and the type will be the WebSocket client message. So it can be either data or text string. In here, we make this an async throw function, and let's just check if the WebSocket session task is exist, and also the connection state must be in connected state. Connection state is connected, then we're going to continue. Otherwise, we're going to throw an error, ns error, and let's just domain WebSocket client and code. Let's just use one for this, and for the user info, and let's use this ns localized description key. WebSocket is not connected. Okay, then continuing on, if it is connected, then we're going to just invoke try await. Okay, let's just use this task send and pass the message. Okay, that's it. We have the send message that we can use to send message from the client to server through WebSocket. Now let's try this. So this is a command line application. So I'm just going to copy and paste from the demo that I've shown you in the introduction. Okay, so this is the OpenAI API key. This is mine, and first let's initialize the WebSocket client and pass this URL. You can use any WebSocket endpoint that you want, but in this case, I'm just going to show you using the OpenAI ChatGPT real-time. Okay, so this is the endpoint. The model is GPT-4o real-time preview, December 1. And then in here, we need to pass the additional headers. First one is the authorization bearer token, which is the OpenAI API key. And then we also need to pass this OpenAI beta real-time v1 as the header. And the ping interval, I set it to 30. So every 30 seconds, we're going to make the ping. And then ping try reconnect count limit is set to 2. So after 60 seconds, if there is no pong, then we will just reconnect. Okay, initiating a new handshake. And then in here, because this WebSocket client is using a global WebSocket actor, we need to switch to WebSocket actor using this task, and then call connect, client connect, and then attach the onReceive handler. It's going to accept the result. In this case, if it is success, we're just going to print this ChatGPT real-time WebSocket server, receive the text that it got from the server. And we also attach the on connection state change closure that will just print the connection state, whether it's connecting, connected, or disconnected. And now just create a loop in here, and then using this red line to accept input from the user of the CLI. And here we just construct this event dictionary. So this is based on the OpenAI ChatGPT real-time API to create a new prompt. Okay, modality is text. I'm not going to demo using audio, maybe in the next video. And then we just pass the input for the prompt. And in here, I'm just going to convert this to JSON string and then switch to the WebSocket actor and invoke the send. Okay, so this is the implementation. So let's try this. Okay, as you can see, it's connected. And let's try to prompt something. Okay, that's the cursor there. What is ray tracing? Okay, send. There you go. We got the answer in real time from the ChatGPT. So basically, ray tracing is a computer graphics technique used to create realistic image, blah 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 blah. Okay, and then it's going to send the ping and pong. Now I'm just going to show you when I disconnect. Okay, as you can see, it will fail to basically connect. And then when I switch it back to on, it should reconnect. As you can see, it's connected back in here. Real-time WebSocket server receive. Nice, right? So basically the network monitoring works as well as the schedule ping. Okay, so that's basically for the implementation of this. And yeah, today we have built a custom WebSocket client with a ping scheduler, network monitoring, and Reconnect Mechanism with a simplified API to the user. So basically, you can extend this to handle more use cases, more edge case scenario. Okay, for example, if you want to add authentication or message realization, okay, you can also handle that as well, extend that. And that's it for today's ByteCast episode. If you found this episode helpful, don't forget to like, subscribe, and hit the notification bell. See you in the next one, and let's keep on being a lifelong learner. Goodbye.